Welcome everybody to today's IBM Spectrum Protect Plus blueprints and sizing tool. Today we have Jason Basler, who is our Spectrum Protect and Spectrum Protect Plus architect, as well as Austin Cook, who's our Spectrum Protect software advanced technology expert, and we'll be talking about the sizing portion. So today's flow is Jason is going to walk us through the blueprints, and then we're going to turn it over to Austin to show the sizing tool. He'll do an actual demo with that. So with that, Jason.
Okay, thank you, Tricia. Welcome, everyone. Thank you for joining the call. By this point, many of you are probably already familiar with the Spectrum Protect blueprints. We've had them available for Spectrum Protect for many years. We have recently released them for the new product, Spectrum Protect Plus, initially released towards the beginning of April and lined up with the 10.1.1 release of Spectrum Protect Plus. I think you'll find many things in the Spectrum Protect Plus blueprints that you're familiar with. Certainly they serve the same purpose that we've had with the traditional Spectrum Protect blueprints. We've provided reference architectures that are available to you to follow and use as an example. Essentially, we are giving you a cookbook to success that you can either follow exactly or use them for inspiration to help you build your own variation of an implementation. We're providing the reference architectures just as we've done for Protect, but we've taken a bit of a different path as far as sizing goes. So sizing is certainly a very complicated part of deploying a data protection solution. And we have developed a tool that takes some of the guesswork out of that process. So we will be sharing that tool with you here, and that tool is publicly available, posted on the blueprint site. So I guess probably the most important thing here on this page is the link at the bottom where you can go to find the blueprints. They're out in DeveloperWorks, and on that page you will find the PDF document, which is the blueprints, as well as the Excel spreadsheet, which is the sizing tool. And here in the green box we have some notes that answer the question, well, how are the blueprints different than the traditional blueprints that we've had for Protect? So first of all, they serve many of the same purposes, but unlike the Spectrum Protect blueprints, we're offering one size blueprint here for Spectrum Protect Plus. We don't have the small, medium, and large configuration that we do have on Protect. Although I'll say the blueprints are going to be continuously evolving, and that's one point where we've had some feedback that getting the different size references would be helpful. And that's something we'll be revisiting in a future update. The Plus blueprints also do not include any automated scripting the way the traditional Protect blueprints do. So, I mean, the simple explanation for that is that Plus is so easy to work with, there really wasn't the need to develop configuration automation in the way we had to for Protect. Although that's another area where over time we may add some additional capability there, particularly around the area of performance evaluation. And certainly the other big difference is that we've made a sizing tool available here for the Plus blueprints. And so those of you working with Protect and the Protect blueprints for some time probably are aware that we also have a sizing tool available for the Protect blueprints. We've just never been able to make that publicly available. And so the departure here for Plus is that we have a sizing tool that not only can our technical sellers and business partners access, but really customers can use it directly as well. The blueprints follow a very easy to follow flow. We have kind of a task overview of what you'll be going through as you implement the blueprints. Certainly you can use all of these steps or pick and choose steps that are important to you. But let's begin with step one. Is really quite straightforward. You have to deploy your Spectrum Protect Plus server. Really, the blueprints don't go into a lot of detail on this because this is such a simple step to accomplish, and the user's guide covers this quite well. Spectrum Protect Plus server is always a virtual appliance. It's as easy as importing it and powering it up in many cases, but that's always the first step you need to begin with. Then the blueprints present a number of technology choices that you'll want to review and make some high-level decisions on, which will then influence how you interpret the remainder of the blueprint. And I'll be walking through those here and presenting some of those choices to you and giving you some of the rationale that you'll want to evaluate when looking at those choices. The next step is that you use the sizing tool to help determine some important characteristics of how you'll implement things. And the blueprints cover two primary pieces that where you'll need guidance, and the first is on the VSnap storage repositories that you'll be building. So the sizer helps you determine the capacity that you'll need for those and the quantity. And then if you're protecting VMware data, another component you need to plan for is the VADP proxy component, and the sizing tool will help you determine the number of proxies that you need. And as the next step, you'll be planning the hardware that you need, and that will be influenced based on some of the technology choices that you made in the earlier step. Then finally, the blueprint will walk through some detailed configuration steps for the VSnap servers and proxies. And so I'm going to go through those sections fairly quickly today. That's an area where you can review the details in the blueprint offline, but I'll be pointing out a few key concepts as we step over that before I pass it on to Austin to go through the sizer demo. There are a number of building blocks to Spectrum Protect Plus that are important to understand. I've already discussed the Spectrum Protect Plus server. Just a bit more detail on that point. So first of all, as I mentioned, it's a virtual appliance. It can run either in VMware or Hyper-V. It includes a web server that provides the user interface for Spectrum Protect Plus. It also contains all of the catalogs that are used to keep track of everything that Spectrum Protect Plus manages. So it's the orchestrator and management entity that runs the solution. One thing that is different with Spectrum Protect Plus versus Spectrum Protect is that the Spectrum Protect Plus server is not in the data path. So unlike with Spectrum Protect, where you're sizing a server that needs to be very capable for running a high-performance DB2 database and so forth, Spectrum Protect Plus server does not require as significant of an investment in resource. More of that work is done in the VSnap repositories. Next, we have the notion of a site. So a site is used to collect your storage repositories into a management entity. So typically a site will correspond to a physical location. So for example, you may have data centers at different physical locations that will each be a site. Kind of at a more basic level, it's used to manage the placement of data, and you'll see here at a later example some scenarios where it makes sense to have more than one site per location. A key component of the Spectrum Protect Plus solution is VSnap server includes a pool, and so this is the storage that Spectrum Protect Plus uses to hold not only backup copies of your data, but provide the data reuse capabilities that are a critical element of the value provided by Spectrum Protect Plus. And finally, we have the VADP proxy, which is the data movement engine that is only used for the protection of VMware data. So if you are building a solution that, for example, will only protect Microsoft SQL databases, you would not need the VADP proxy component. Likewise, if you're implementing a solution for Hyper-V and not VMware, you would not require the VADP proxy component. We'll look at two different deployment patterns here. One key capability that was introduced into Spectrum Protect Plus 10.1.1 is the ability to replicate data that is in the VSnap repositories. So part of your site planning will be to plan how to implement replication of your data. So a very common pattern will be implementing Plus at two locations using replication, where you'll be performing a two-way or a bidirectional replication. So at each site, the VSnap repositories will not only receive backups, but will also replicate those backups to another site. So VSnap servers act as both a backup target as well as a replication target. A couple of key points to note that are spelled out here on the chart. So the first is there is only one Spectrum Protect Plus server. Unlike Spectrum Protect, where you'll potentially have many servers cooperating together potentially, in this case, one Spectrum Protect Plus server is expected to be able to manage your entire environment. You also notice we have defined two sites, so each physical location has a site defined. In this case, they've been taken the default naming convention of primary site and secondary site. You'll also notice that there is also multiple VSnap servers as well as VADP proxies. Now, one of the purposes of sites that I didn't mention on the previous slide is that sites are a way of grouping things together to avoid data movement having to go across long-distance network pathways where it's inefficient. So, for example, at the primary site, you have vSnap servers, VADP proxies that would be partnered with the VMware data centers at that location so that the backup flow stays within that physical location, and the only data movement across the wider network will be the replication traffic. If we move on and look at the second configuration, in this case you have the notion of a primary site and then smaller branch sites, where the branch sites replicate into a larger vSnap implementation at the central site. So this would be a useful pattern of implementation for things like remote offices. Again, you have a single vSnap server that manages the components at each site. One thing that is not shown on this chart here in order to keep it simple, is that you would likely also be replicating the data at the central site off to another location. That is the data that's being protected at the central site. So that VMware data up at the top of the central office there, you would want to keep a replicated copy of that somewhere else, but you would not be re-replicating the data that comes in from the other sites. So there's really two major choices that you need to start with. The first of those is, where do you want to implement RAID for redundancy against disk failure in the vSnap repositories? So the first choice is that you'll use a software-defined RAID feature that's provided as part of the vSnap software. This allows you to use very inexpensive JBODs of disk where you do not need a hardware controller capable of implementing the RAID. So it implements a variation of RAID 6 in the software that has a number of advantages. The first is that it's, as I mentioned, very inexpensive. It also has some resiliency built into it that you do not get when you use hardware-provided RAID. So the RAID system in vSnap records checksums of all of the data stored within the pool, such that when it's read back for anything such as a restore scenario or a replication, those checksums are validated, and then if a mismatch is detected, it is able to read from the redundant copy off on another disk, and in some cases repair the damaged copies from that redundant copy. This is a very scalable and resilient system. Certainly a good choice for implementing, if you're going to be kind of jumping ahead to the next slide, is whether you're choosing physical or virtual repositories. So you'll see cases where it makes a lot of sense to build physical vSnap repositories where you implement the software-based RAID. The second option is that you'll use the redundancy, the RAID that's built into your hardware storage system. In this case, you might be using something like an IBM Storewise device, which has the ability to provide a very advanced distributed RAID mechanism within the hardware itself. In that case, you do not need to use the software-based RAID that's available in the vSnap. I guess kind of the bottom line here is you don't want to use redundant RAID. So we don't want you using RAID both in the hardware storage system as well as using the software RAID. We want you to choose one or the other. So doing it redundantly not only would waste a lot of capacity, but would have a fairly negative impact to the performance you're going to get out of your vSnap. So some obvious reasons why you might want to use a hardware RAID. One is you've made an investment in a storage technology, such as Storewise, where you already have a very effective RAID system to protect you against disk failure. It will have management interfaces that you're accustomed to, and you don't have to learn a new management system. So if you're going to use the vSnap RAID, it's very powerful, but there are some things, for example, monitoring for disk failures and replacing failed disks, where you'll have to learn a new software-based approach to maintaining that. Whereas with the hardware-based RAID, you'll have facilities that are more familiar to you. But so the bottom line is, you choose one of these. If you're going to use the software-based RAID in vSnap, you will implement your vSnap pools using the vSnap RAID 6. If you're going to use the hardware RAID option, when you implement your vSnap pool, you will choose RAID 0. The second major choice, the data reduction technologies that you want to use. So vSnap offers the ability to do both compression and deduplication. Compression is on by default. Deduplication is off by default. It's very easy to enable. So similar to the container pools we have in Spectrum Protect, compression and deduplication can work together to provide a very significant amount of data reduction. Certainly, we would strongly recommend that you always use compression. We'll likely provide to you at least a 2-to-1 reduction in capacity, possibly more. It is fairly low cost in terms of the impact to performance. The only time that you would not want to elect to use compression is if the storage system you're using is going to be providing compression. So again, that's an area where we wouldn't recommend that you want to redundantly compress in both locations. But in the event your storage system is not using compression, then we would strongly recommend that you use compression. Deduplication is, takes a bit more consideration. So certainly deduplication has the ability to provide a significant storage savings. And when combined with compression, quite a bit more storage savings would be possible. But with deduplication, so you'll be making, essentially it boils down to making a trade-off between the cost of your solution in terms of saving storage versus how well it's going to be able to perform. The impact to performance is primarily at backup time. So you will be trading off some of your sequential write throughput as, a means to obtain that data reduction. There is also an impact to the planning for the vSnap server because deduplication requires resource costs in the server that's running vSnap. You will need to allocate additional CPU and memory for the purposes of doing deduplication. That is a performance versus capacity savings trade-off. I will point out that, I mentioned the performance trade-off is significant at backup time. There is some impact for the data reuse scenarios, but by no means is it as severe as an impact as it is on the backup throughput side. Your next technology choice is whether you'll be using physical or virtual vSnap server deployments. So I mentioned the Spectrum Protect Plus server is always going to be a virtual machine. In the case of the vSnap server, you have a choice. When you download Spectrum Protect Plus, there are two variations of the vSnap software. The first is provided as a virtual appliance, an OVA file or a Hyper-V virtual appliance that you can deploy the vSnap engine as a virtual machine. That is beneficial in a number of ways. First of all, is it's very convenient and easy to deploy, easy to manage. It's easier to customize and fine-tune your vSnap pool capacities and so forth. But then there is some risk that you have to manage the space a little more carefully. The blueprints provide an example where we're assigning virtual disks as raw devices. In the case of VMware, that's using PRDM. That's a very convenient way to assign storage such that you can use the entire capacity. It's also possible, of course, to assign storage to vSnap through VMware file systems as virtual disks. If you're going to do that, the blueprints give you some guidance on avoiding situations where you might run out of space within those data stores. That's really, you want to take a lot of care to make sure that you fully provision the storage to vSnap so that what it thinks it has available to it, it will be able to write to fully. Kind of a footnote there, we don't recommend that you take hypervisor level snapshots of vSnap. Because first of all, there's obviously a lot of data being written into vSnap. It will generate a humongous amount of change activity within the snapshot that will grow a lot into the free space of your virtualized file systems, but will also, degrade performance, and if you run out of space, could be fairly catastrophic to vSnap. PRDM is one way to just avoid all of that management nightmare. If you are going to use virtual disk devices, then thick provision them, and we even recommend that you take some steps to prevent snapshots from being taken that are detailed in the blueprints. Your other option is to deploy vSnap as a physical server. So the other variation of vSnap is an installable software component where you bring your own operating system and add the VSnap software. In this case, you lose the simplicity of deployment and the kind of convenient management of those entities within your virtualization management infrastructure, but you get the advantage of having isolation from the hypervisor environments you're protecting and your backup repository. So kind of this is avoiding having all of your eggs in one basket scenario. You also avoid having to pay the licensing costs for the virtualization layer of running VSnap. Of course, the disadvantage is you have to bring your own operating system. You have to manage it as a physical machine and so forth. So really there is no best option here. It comes down to preference. I would say if you are going to be implementing virtual VSnap servers, then you need to do extra planning to make sure you are avoiding having all of your eggs in one basket. So you need some separation of the backup infrastructure from your production infrastructure. For example, you may want to implement different disk arrays for holding the backup data than what's holding your production data, and you should probably also dedicate host systems for running those elements. And then you also have to do some further planning on recovery scenarios. For example, if you lose your virtualization environment and you have to go through restores, you'll need a virtual center in order to run Plus and to begin doing those restores. So either option is suitable, but the blueprints, certainly you'll want to read through this section. We give a lot more detail on making these choices, and this is an important one. As far as this technology goes, the blueprints give you some guidance. So first of all, the pool capacity for VSnap, the blueprints are recommending low-cost nearline SAS capacity, which is very suitable for the streaming backup workloads. We also recommend a small amount of SSD or flash for optimizing performance, and there's two parts to that. There's a log, which optimizes the sequential write performance. That's the I/O pattern of the streaming backup sequential writes. The cache is a feature which can, if you're using deduplication, optimize the lookup for deduplicated extent, so that improves backup performance when using deduplication, but it also optimizes the random read patterns that are going to happen when you're going through the data reuse scenarios. So in the data reuse scenarios, volumes are mounted. They will be going through random read-write patterns that are common from doing something like, let's say, running a virtual machine out of VSnap. There may be some cases where you'll want to build VSnap repositories with very high-end disk, more expensive disk technology than nearline SAS, where you can use the SLA facility within Spectrum Protect Plus to designate certain critical virtual machines or applications to go to that fast storage. So for example, you might want to implement some type of all-flash array, implement a dedicated site for that, targeting that all-flash VSnap, and then directing some of your critical systems to back up into that all-flash array. Now, for implementing sites, I mentioned this briefly already, but the key component is that you want to encapsulate things within a site so that the data flow for backup and data reuse occurs on the local networks within that site rather than jumping across between sites. And so some rules of thumb to make sure that happens. The first one's rather obvious, but you always want to have at least one site definition per physical location, and you should have at least one VSnap for every site and one VADP proxy at every site. And so certainly Plus makes it very easy to scale out to larger environments by adding multiple VSnap repositories and multiple VADP proxies, but you should always at least have one at every site. There may be some exceptions here where if you have a really small site without the infrastructure to implement another VSnap and proxy, you could consider, if your network will support it, having backups jump across the wider network across sites. But in most cases, you'll want to follow these general rules. And as we mentioned, there are some cases where you may want more than one site per location, and jump ahead and show an example here. And so in this example, replication, there's a variation of replication here where you want to dedicate VSnaps for the purpose of being replication targets. So in this case, you have made a decision not to use a VSnap both as a backup target as well as a replication target, and this is accomplished by making multiple sites at a location. For the first site is the backup target, and then the second site is the replication target. And you can see how the backup target at each physical location is partnered with the replication target at the other site. So the blueprints give you some more detail on how to implement this variation if that's something that your business process will require. Now finally, the VADP proxy, like the VSnap, or I should say unlike the VSnap, there is currently no virtual implementation of the VADP proxy. So the VADP proxy is always a software package that you will install over an existing operating system. But like the VSnap, you have the choice here for this to be either a virtual machine or a physical machine. The kind of rationale we used for VSnap for physical versus virtual, many of the same considerations hold true here for the VADP proxy. But there are some nuances as far as the transport modes that you'll be able to select. And so in the VMware case, the data movement path between the hypervisor and the proxy is known as the transport. And VMware offers kind of a universal one, which is known as NBD, which allows that data flow to occur across the network. That's the easiest to implement. You can use that either in the physical or virtual case. But VMware also offers a hot add transport mode, which is available when you're using a virtual proxy. So in that case, the data flow between the proxy and host can go directly across the SAN to optimize performance. It is possible to have a group of proxies that are load balanced together at a site, and that's very easy to accomplish by tagging the proxies. You'll see here in this little screenshot, when you deploy a VADP proxy, you associate it with a specific site, so it's very possible to have more than one proxy associated to the same site. And one last note here, a recent addition to Plus was us offering the ability to stack the VADP proxy and the VSnap server together on the same system. This is particularly useful in that remote branch office scenario we showed the chart for earlier, where you may not have the hardware infrastructure to keep these separate. Keep the solution simpler and have fewer servers to manage. If you're going to do this, the kind of key point the blueprint lays out is that you need to account for the resources for both the proxy as well as the VSnap to make sure you're not undersizing one of those two elements. Let's jump now into the reference architectures. So the blueprints give you two tables to help you in planning some different capacity allocations for VSnap. And there's two tables. The first covers the case where you'll be using both deduplication and compression. The second table covers the compression-only case. You'll notice a couple of things. First of all, when you are using deduplication, the CPU and memory allocation is larger. We also are using compression only, possible to scale the VSnap capacity to larger capacities. Now, in addition to the CPU and memory scaling up for larger capacities, of course, you'll be providing more storage for the pool. And you'll notice we are breaking the pool disk across multiple LUNs. We will say the actual quantity and sizes of these pool LUNs is not overly critical. Some general, rules of thumb we were following and making these is we didn't want the capacity of any one LUN to become too large. But also it's important for the resiliency of VSnap to have more than one pool LUN. We would say, if possible, have at least 3 of them. You'll notice in the case of the really small, that wasn't practical. So at a minimum, have two LUNs. If possible, have 3 or more. And then the log and cache, as I mentioned, are optional. They optimize performance, and the general thinking here is that at the smaller sizes, for example, with a 1 terabyte VSnap footprint, you're unlikely to have the throughput demands to write into it where it would require the log or cache. You certainly could add them if for some reason that makes sense, but we figure in most cases at those capacities they wouldn't be necessary. The log, you have the option to mirror the log, which you'll notice there's 2 of those devices listed. That is, again, a trade-off. There is some performance impact by mirroring the log on the sequential writes during backup. So here you're making a decision between having sort of the best possible redundancy versus the best possible throughput in the decision of whether or not you'll be mirroring the log. The VADP proxy recommendations, the user's guide goes into a lot of good detail for the configuration of the proxy, but we definitely recommend you follow the user's guide recommendation of having 4 CPU cores and 16 gigabytes of memory. If you're going to be stacking that on the same system as VSnap, you'll need to account for that hardware as well. A general rule of thumb that you can follow is to have one proxy for every 100 terabytes of VMware front-end data that you'll be protecting. A couple of tips on the proxy. There's a proxy configuration page that you'll see there. One is that you can provide a list of transport modes. We recommend that you reduce that list down to only the transport modes that proxy is capable of performing. So for example, in many cases, it will be unlikely that you have implemented things to be able to use the SAN transport, so we would recommend you take that out of the list. That will allow the proxy to operate a bit more efficiently. Another configuration choice is whether, if you're going to be using the NBD transport type, VMware provides the ability to compress that traffic. We recommend you disable that if you have a 10 gigabit network. It will not help with your performance. If you have a slower network, such as a 1 gigabit network, then you should consider using the compression. The blueprints provide two different configurations to consider, and they implement two of the major technology choices that we reviewed in different ways. And so the first that we've provided is a physical VSnap repository using the software-defined RAID provided by VSnap. And you'll see here in a minute our other combination is a virtual VSnap using a storewise system which provides, of course, hardware, RAID in the storage hardware. So let's start with this first variation. So we have implemented a Supermicro storage dense server, which has 36 internal nearline SAS drives. You have 24 of them in drive slots in the front of the server and 12 of them in drive slots in the back. There are also 2 drive slots in the back to boot the operating system. We are using some NVMe storage within the server to provide the log and cache capacity. So those nearline SAS drives that we're specifying have a 10 terabyte capacity. And so this system provides 205 terabytes of usable pool capacity after you account for all of the capacity that is used up for providing the RAID redundancy. In this case, we're saying this is a physical VSnap, so you would be installing your own operating system on this system. In the case of the blueprints, we're recommending that you use Red Hat. CentOS is also an option. Now, we're showing this example as a physical VSnap. There's certainly no reason why you couldn't install a hypervisor on this system and use the combination of a virtual VSnap with the software-defined RAID. But we figure kind of the most common case here is these will be implemented as a physical implementation of VSnap. So a couple of key points. The CPU and memory allocation that you'll see here at the bottom are designed for implementing both compression and deduplication. This uses a 10 gigabit Ethernet connection. Certainly you will want to implement this on a 10 gigabit network if possible, as you will be using a significant portion of that bandwidth, the backup throughput that you'll be able to drive into this system. As I mentioned, we have 2 NVMe adapters that will be used for the log and cache so that you will have very optimized backup throughput as well as data reuse performance out of this system. The next variation, as I mentioned, is what we've positioned in the blueprint as a multi-purpose hypervisor storage, and this is built upon Storewise. We are using the Storewise V5000 or the 5020 variation of that system, as well as the storage dense expansion that's offered with that system. So that's a 92 drive, 3.5-inch expansion. So if you load that full of 92 6 terabyte drives, you have closer to 400 terabytes of usable nearline SAS capacity. We're also implementing some of the read-intensive large capacity SSDs in the controller itself, which will provide 11 terabytes of SSD capacity in a distributed RAID 6 configuration. Now, the reason we call this a multi-purpose hypervisor is this is very well suitable to not only implementing VSnap storage, but you also may want to use some of that SSD capacity for other purposes. So as one example, deploying the Spectrum Protect Plus server virtual appliance benefits from dropping that on a data store carved out of that SSD capacity. So all of the catalogs operating system features of that Spectrum Protect Plus server appliance will benefit certainly from running on SSD. You can also use that SSD to provide the log and cache capacity to the vSnap servers. So again, this storewise system could be used either as physical or virtual implementations of vSnap. You certainly could implement vSnap on physical servers without a virtualization layer and then assign volumes off of the storewise device to those operating systems. Or you could do virtual implementations and assign the storewise capacity and build up data stores within your VMware environment, for example, to assign that capacity. So that is it for the references. I'm going to jump ahead here for a minute and just say there's a number of slides here that will be provided that really detail what's already available in the blueprint. I'm going to kind of introduce the type of information that's in this section, then we'll leave it as an exercise to everyone to go read through these slides, as well as find the information in the blueprint document itself. But vSnap provides a command line interface, so certainly it's very easy to get started with Plus. There's a vSnap that's built into the appliance that you can do some initial work with. It's also possible to configure vSnap from the user interface. But for fine-tuning vSnap for performance and building the custom configurations that's in the blueprint, you will likely need to use the command line that is provided in the vSnap software. So the blueprints give you all of the commands that you need to do to build up a vSnap. And so as an example, when you have a new vSnap, you initially set it up using the vSnap system init command. By default, it will give you a pool. We have you use the Skippool option so that you can do a more advanced pool creation. And just as an example of that, we'll jump ahead here and you'll see some vSnap pool create commands where we're tailoring things like whether you want to use RAID 0, or jump ahead on the next slide is an example of where we're doing the RAID 6 case. So again, all of that capability is provided in the vSnap command line, and we give you what you need to know on how to interact with that interface. All right, so I'm going to pass it over to Austin so he can jump into using the sizing tool.
So my name is Austin Cook, and I'm going to cover the sizing tool portion of the blueprint presentation. So that's going to involve utilizing the Excel spreadsheet that's publicly available to download. However, before I do that, we're going to just briefly take a look at a sizing tool example that we're going to use for the demo. As Jason mentioned, we have two Spectrum Protect Plus has this notion of locations. So in this example, we're going to have two sites or two locations that we're going to size for. At location 1, we have a VMware data set that we're going to protect, as well as a Microsoft SQL data set that we're going to protect. So 100 terabytes of VMware, 50 terabytes of SQL. At location 2, the other site, we have a workload, Oracle workload of 200 terabytes that we're going to protect. So for both sites, we're going to have 30 days of daily backups for our retention. And then in addition to that, we're going to have weekly backups for 180 days for our VMware data. All sites will replicate, so we're going to have bidirectional replication. We're going to enable deduplication in addition to compression for active vSnaps. And then we're going to size for 3 years out. So now I'm going to switch over to the Excel spreadsheet. When you open up the Excel spreadsheet, you're going to be presented with a basic notification box about macros. The Excel spreadsheet has some custom formulas to assist with the sizing. That's why this message pops up. So what you want to do is enable the macros. And then the next thing that happens is a disclaimer notification pops up. This is summary, your mileage may vary as you're doing the sizing. We're going to press OK and close that out. Also, every time you open up the spreadsheet, it will take you to the Start Here tab. So what the Start Here tab has, it's a list of the global options. So at this point, you need to make the decision whether or not you're going to implement compression after vSnap or deduplication. We also have some reserve percentages here, as well as some network speeds and feeds. We have compression enabled. This is default for VSnap repositories. You have the option to enable deduplication. You also have the ability to adjust your compression and deduplication estimates. So in the event that data you're backing up, you know that you typically get a 3-to-1 compression ratio. You can adjust that if need be. If you're not sure, best to leave the compression and deduplication estimates at their default value, 2-to-1. Combined together with deduplication and compression, 2-to-1 each, that gives you an overall 4-to-1 data reduction estimate. VSnap reserve, so the default's 20% for this. The intent here is that you want to have some working space for your data reuse and test operations that you perform with Spectrum Protect. You also want to have some working space to prevent filling up your file system to 100% full. Networking, default 10 gigabits. However, if you believe that your 1 gig network, you can make those adjustments here if need be. So we have the network speed for your VMware ESX host to the VADP proxy. And then we also have a network selection for the VSnap repository itself. Now click on, we have several client tabs, VMware, Hyper-V, Oracle, and MS SQL. So for Site 1, we have a VMware workload. So we're going to click on the VMware tab. So in the example, the VMware workload, we have a daily change rate of 7%. I've already entered that in. The default's 5%. Annual growth, for example, is 20% annual growth. This is compounding annually. Workload, we have 100 terabytes, and we need to back that up daily with a 30-day retention. The silver policy meets that criteria, so we put in 100 terabytes front-end data. Our retention is 30 days. We enable replication, and then the replication retention is the same as our primary site retention. We also have the requirement for VMware to retain weekly backups for 180 days. So we've entered in 100 terabytes of front-end data again. We have our backup frequency at weekly, and our retention is set to 180 days. This data is replicated as well, so that replicate policy question is set to yes. And the replication retention is set to 180 days as well. Okay. So below we have some subtotals for this client workload. This is a VMware client workload. In blue, we have speeds and feeds. So what kind of rates are we estimating for this client backup workload? And that's displayed in megabytes per second. And then in the green section, we have our capacity. So how much front-end data are we estimating, total managed data, our data reduction estimates in dedupe and compression, and then we have a physical capacity estimate. Now, not only do we provide an estimate for the current year or current needs, we also have a 7-year projection. So each column applies that annual compounding growth rate to show you what your requirements are for the future. We also have a replication copy. So if you enable replication, and based on your retention policies for replication, we'll provide the subtotals for your replication requirements as well. Site 1, we also have a MS SQL workload. So I'm going to click on the MS SQL tab. And in here, we have those the same client options, daily chain rate, and annual growth. For customer scenario, we're going to keep those values as default. They're fine as is. We have a 50 terabytes of front-end or used capacity of MS SQL database that we need to protect. Again, we want to protect that, back it up daily, and retain it for for 30 days. So the silver policy is the best fit. We put in 50 terabytes. We're going to replicate that. We click yes. So just like the VMware client, we now we have our subtotals for the primary copy as well as the replication copy. So at this point, we've put in our values for VMware and the MS SQL clients. So we've completed our sizing for Site 1, and now we can click on the Sizing Results tab, and we can get a summary. This just summarizes all the inputs from each client tab and summarizes the results. So again, we have the primary copy results, and in here we have our speeds and feeds, just like the other subtotals, as well as our capacity estimates. Couple things that we have available here is we could, if we want to look at rates in different formats, default's gigabits per second, but if I want to see terabytes per hour, I could easily make those changes. Everyone's different and wants to see the rates in a different format, so I have a few options that are available. Also, as you see down here in orange, we have a preferred VSnap size. So depending on our workload and our physical capacity estimates and that front-end rate, we have the option to possibly reduce the VSnap quantity. So if we go with, let's say, a 200 terabyte vSnap repository, we could reduce our vSnap quantity. And depending on what building block you want to use, this could be really handy to adjust. You might want to go with 25 terabyte vSnap repository. When we do that, that creates quite a lot of vSnaps here. That may or may not be what you want to do and how you want to scale out. So we have the option to scale up to different size vSnaps. And it's factoring in not only the physical capacity estimate, but it's also factoring in your front-end rate. So in the event that you have a very high front-end rate, that might be what's scaling out and requiring a larger quantity of vSnap repositories. So depending on your front-end rate and your physical capacity, one or both of those may be driving the quantity of vSnaps. Okay, so we're going to go with the 200 terabyte vSnap building block here. So when we look at year 2 projection for our primary site, we require 3 vSnap servers at 200 terabytes each. And then we, based on our VMware workload, we also need 3 DADP proxies as well. For our replication copy, since we need to replicate this data as well, we have a peak replication rate of 3 gigabits per second. So that's critical for ensuring, for your WAN pipe between your sites. For this workload, I need to have dedicated 3 gigabits per second to replicate the my Site 1 workload in my desired replication window. Managed data and physical capacity estimate is going to match my primary copy because the retention values are identical. Now that I've completed Site 1, what I would typically do here is I would save this Excel spreadsheet as primary, and then what I could do is I could go back to the Start Here tab, and I'm going to now size for my secondary site, Site 2. So I'm going to click this red button here at the Start Here tab, and what this is going to do is it's going to clear out all the inputs that I applied and reset everything to the default values. We have 200 terabytes of Oracle data that we need to size for. And we're going to use deduplication for the VSnaps, just like the other site. All the other values stay the same. I'm now going to click on the Oracle Client tab. So in our customer example, our daily change rate for the Oracle databases that we'll be protecting is 2.5%. I'm going to make that change. And we have 200 terabytes of front-end data that we will need to retain for 30 days. So again, the silver policy fits those requirements. So I'll put in the front-end amount of 200 terabytes. And then the replicate policy, I'll click yes. And we're going to have the same replication duration of 30 days. Replication retention of 30 days. So just like the other client tabs, we have our subtotals. We don't have any other client workloads for Site 2. So we click on the Sizing Results tab and look at our results. Scroll up here. Okay, so for the primary copy, again, we don't have quite the same front-end rate as our other site. However, we have a larger amount of front-end data. So right off the bat with the default 100 terabyte VSnap size, we're looking at 2 VSnap quantities. However, if we change this to 200 terabytes, we could reduce the VSnap quantity down to 1. Okay? For a replication copy, since we have the requirement to replicate this data, we require dedicated 0.6 gigabit per second of bandwidth between the sites. And again, since our retentions are identical between the primary copy and the replication copy, our VSnap physical capacity estimate and VSnap quantity for both primary and replication copy are identical. Okay. Performed our sizing for Site 1 and our Site 2 independently. So what we need to do at this point is we need to summarize the results to understand the total VSnap requirements at each site, as well as our bandwidth requirements for replication. I'm going to go back to the PowerPoint slides here, and we'll take a look at our results. So from our demo example, here's the summary of our results. So we have the primary site, Site 1, and our secondary site for Site 2. We have our ingest and replicated data amount. So each site is going to be doing bidirectional replication. So in total TB for each site for a VSnap repository, we need just over 600 terabytes of data. Based on our VSnap building block of 200 terabytes, we need 4 VSnap repositories at each site. Primary site is backing up a VMware workload. So at that site, we need the VADP proxies for those backup operations. However, if the secondary site is strictly a VR recovery site, for VMware, we do not require the VADP proxies at the secondary site. The WAN bandwidth, we need to sum the values up between each site since we're doing bidirectional replication. We have secondary site has 0.6 gigabits per second of required bandwidth, and the primary site has 3 gigabits of bandwidth requirements for replication. In total, we need 3.6 gigabits per second of bandwidth for bidirectional replication between both sites. And that is the end of the demo as well as the presentation. Tricia, would you like to open it up to questions at this point?
Yeah, so let me walk you through some of the questions that came through the Q&A log. There were lots of questions about what to do if your Spectrum Protect Plus server was lost and how vSnap replication as well as the catalog backup work.
Maybe I'll just quickly mention that certainly you mentioned we have the catalog backup feature. Those catalog backups can be driven by an SLA, so they're scheduled to occur as frequently as you require. So those backups write into vSnap, and then that is also eligible to replicate. So the recommended approach would be that you schedule those catalog backups to happen frequently and that you define the SLA so it replicates those catalog backups. Certainly then if you lose your Spectrum Protect Plus server, you can deploy a new OVA of the Spectrum Protect Plus server and then do the catalog restore to get back everything that you needed from a metadata standpoint. Now, another scenario aside from just losing the SPP servers, you may want to test DR, for example. So you might have a scenario where at your replication target site you would want to deploy a new SPP server and test the restore of the catalog backup and then test some restores from the replicated copies. And so in the 10.11 patch 1 update that was just recently released, there's an enhancement that was made to catalog restore where you can choose to do a catalog restore in a test mode. And what that will do is bring up your restored SPP appliance in a mode where all scheduled activity is disabled so that it will not interfere with your production SPP appliance that is still running in production. And
there was also questions on how many sites could replicate to a central site, and as I understand there is no limit to that, correct?
That is correct. The limiting factors would be things like how much VSnap capacity will the sizer tell you that you're going to need, and what's the incoming network bandwidth at that site. So, there's obviously practical limitations, but there's nothing architecturally designed into the product to limit it.
Okay, and then there was a question. The daily replication duration is in hours. What is the network WAN bandwidth? Is it assuming the same as the local network?
It is not in Austin. I think you probably showed that on the sizing results where those different throughputs are called out, right? And so, one practical example is the bandwidth you need on your primary site accounts for the data movement into vSnap before data reduction, whereas the replication bandwidth benefits from that data reduction. But the sizing spreadsheet does call out the actual replication bandwidth that's required, and that is influenced by the duration that you set for how long you're going to allow replication to run.
Is there any best practice recommendations for vSnap size?
So one, starting at what's the largest you want to allow it to get. So the blueprint in that table I showed you has when you're using deduplication and compression, we make the recommendation that you limit the size to 200 terabytes. When doing compression only, we're showing you a kind of a largest building block of 400 terabytes. Again, this is another area where architecturally vSnap is not prevented from getting larger than that. That's where we kind of drew the boundaries from where our testing wrapped up here in the first release of the blueprint. So that may be an area where the compression only will show larger capacities in the future. But for now, we recommend you keep the capacity, certainly of the deduplication implementations at 200 terabytes of usable capacity per vSnap and 400 terabytes for compression only. Keep in mind, it's certainly possible to scale out with more than one vSnap. You can have multiple vSnaps together in the same site definition to get to logical capacities greater than that.
The next question, can the data be moved from one vSnap to another, or does the SPP server balance the workloads across all the storage?
The only facility for moving data between vSnaps is replication, and that's more for a mirroring. There is no after storage rebalance capability currently in vSnap. It is possible to, as I mentioned, define multiple vSnaps in the same site, and the workload is balanced across those. But once it's been stored, there is no relocation capability.
Final question that didn't get answered, is there a recommended migration strategy to populate the new Spectrum Protect Plus environment.
Can we get an elaboration on that? Is that a question of transition from Spectrum Protect for VE to Plus?
Yes, from Spectrum Protect for VE, migrating over to the new Spectrum Protect Plus environment. What is the recommended migration strategy?
Okay. Well, I guess we'll start with first some things that are not possible. So it's not possible to transition recovery points that are stored with VE in a Protect server into the VSnap environment. So there is no migration of the data component. So this would be more of a, bring up the new Plus environment where you'll have to start with new base backups, get into a steady state, and at some point, cut off the VE backups and then let those existing recovery points expire off according to your policy. Some other topics that come up in this conversation is reuse of the hardware components. And so one obvious one is that the data movers, the proxy systems that you're using in VE, have very similar hardware requirements to the proxy component of Plus. So those components could be reused as VADP proxies for Plus. It's also certainly possible to coexist the VE data mover installation and Plus data mover on the same system should you have some time period where you'll need to continue using both products. If it obviously comes with some consideration for workload capability of the machine and trying to not overlap backup windows and so forth. Another kind of hardware reuse topic is the Spectrum Protect server and its the storage it's using for container storage pools. Can that coexist with VSnap? And you could have Spectrum Protect Plus server and VSnap sort of side by side using storage from the same systems, but they can't share the same actual storage allocation. VSnap wants to operate on raw block storage, whereas Spectrum Protect Plus server is writing into existing file systems. So there is no way to share that actual storage definition. I guess this is a fairly broad topic where we could probably have a whole session dedicated to it, but that's sort of some high-level ideas around that topic.
Yeah, Jason, there was a question about stacking the VSnap server and VADP proxy on the same system. Do you want to talk about that real quick?
Yeah, I think I mentioned that is supported. The blueprints do cover that topic, and kind of the general thing to watch out for is you need to take the hardware requirements of each of those components and add them together. So, for example, make sure you have enough CPU and memory to run both roles so that they're not starving each other for resources. The other consideration is overlap of the supported operating systems. And where that comes into play is if you want to use the VSnap appliance, which runs on CentOS, then you'll be running you have to install the VADP proxy software into that system. Alternatively, you could do a physical implementation on something such as Red Hat and then install VSnap as a software component as well as the proxy together. So those are the two variations.
Okay, and there was one comment. Just be careful when you're looking at the sizer about terabyte, which is TB, versus tebibyte, which is TIB. So just be careful when you're referring to the sizer with those two units.
Yeah, in general, us software guys with a software background are perpetually annoyed that this manufacturer's had to do anything other than powers of 2, so it takes us a while to convert. But I think in general, Austin, unless otherwise specified, when we say terabyte, we're referring to the power of 2, the TIB.
Correct, and the size is consistent throughout that. It's just where on the summary tab is where you could show the speeds and feeds in petabytes per hour or gigabits per second. So that's the only location where I do any conversion. Otherwise, everything's either in petabytes or the megabyte form of that as well, and powers of 2.
Okay.
Excellent. So with that, I'd like to thank everybody for joining today, and all the best with Spectrum Protect Plus.